Welcome. So now we're going to look at problem number 3. Rectangular pages to contain 24 inches of print. I drew a little picture there. Right? So the print part is making up 24 inches in area. The margins at the top and bottom of the page are 1.5 inches, which I marked. And the margins on the left and right are to be 1 inch. What should the dimensions of the page be so the least amount of paper is used? Now sometimes when you start a problem that's a little novel like this, you try some different things. Right? So I'm going to start with I'll start with my primary equation, but it needs a lot of work because we need to add some, it's too vague, it's got 2 variables in it, so it's a problem. It doesn't include our constraints that we were trying to maximize and minimize. Actually, that's before we even write down the primary equation. Let's write down what it was we were needing to do. And so that's the least amount of paper used. We're looking at area, so we want to minimize area. It's a good idea to write down what it is you're trying to do. All right, so we can start with, that's a rectangular page, right? It says a rectangular page. So area would be the length times the width. I got 2 variables in there, so that's not really a super helpful equation. So then we hope to fix things up a little bit with our secondary equations. And remember one of our goals with our secondary equations, boy, that's supposed to say equation, but it doesn't much look like it, does it? Right, the goal with a secondary equation, we need to reduce this to 1 variable, reduce the primary equation to 1 variable. Right? And then deal with the constraints. There are certain constraints, such as our margins and our area. So some things I tried, so you just try anything. I tried perimeter, but it wasn't very helpful because I ended up with 3 variables. So, because perimeter would be 2 times the length plus 2 times the width. So that one wasn't very helpful. So then I was like, well, the only thing I know is the area in the center there. So then I thought, well, maybe I could add the areas up, right? So, right, here we have an area. The writing part's 24 inches. What about this area? We got this area. Can I write that as an equation? Well, the problem is that I know the height, for instance, of that margin at the top is 1.5 inches, but I don't know what the width is. Right? So then you're just introducing more and more variables. So I was like, okay, well, that isn't helpful. So let's try to step back a bit, and our primary equation is minimizing the area of the outside page, the whole page. Maybe the information we're given we could use to rewrite the area of the center part, right? And just focus on that for our secondary equation. Right? So it would still be, so this would be inside area. So I couldn't do anything with perimeter. There isn't much else for a 2-dimensional. You got perimeter, you got area. So instead, let's go to area again because they're very specific about some of these areas on the inside there. So the area of the inside is going to be the area of that writing part. All right. So what if we called this dimension here x and this dimension y? All right. So my inside area is going to be the x times y. All right, we got to actually, yeah, I'll explain this x and y. All right, so that's going to give us the area of the inside. If x times y, if x is going to be the length on the inside of that writing, and y is going to be the height on the inside of that writing, could we then change up the equation a little bit to change how we're representing length and width? So I think we can do that. All right, so this is inside area. How about outside area? All right, so that's the whole page. I'll write a whole area. whole page. All right, so if this part here, actually on my original, when I was kind of going through this problem, I switched to X and Y. It doesn't matter. You can get the same answers. You just get it for a different letter. All right, so if we call this much X, what will we have to add to X to get the whole page, to go all the way to the outside? All right, so notice there's a 1-inch margin on each side. So for the whole page, the length, or the width, I'll write it second. I'm just used to writing length and then the width. The width there would be X plus 1 plus 1, right, or 2. All right, so now let's look at the length here. So the length is that much for the writing, but what if we wanted to be on the whole page? Well, if we extended it, till we get to the edge of the paper there, we'd have the inside part, which is Y, plus we'd have to add in the margins, right? So that'd be 1.5 plus 1.5, so that would be 3. So now we could replace length and width with Y plus 3 and X plus 2. And you might say, well, did that really make anything better? Instead of L's and W's, you've got X's and Y's. And so far, you're right. It doesn't make anything better, but we're not done. Because one of the problems is we still have 2 variables. All right, so let's go back to this inside part, because we know that inside part has to be 24 inches. So 24 has to equal X times Y. What if we solve for one of the variables? And then we can plug it back into our equation here. And it really doesn't matter which one we solve for. Maybe we'll solve for Y. All right, so, yeah, we'll solve for Y. So we'll divide both sides by Y. And now we could represent X as 24 divided by Y. So now we can go back to our primary equation. And we're going to use this for length and width, and we're going to use that for Y, or for X, excuse me. Oh, I decided to solve for X after I said Y. Didn't matter which one, by the way, I solved for. But we're just going to replace X now with the 24 divided by Y. So now our area is going to be Y plus 3 times X plus 2, but now X has been replaced with 24 divided by Y plus 2. All right, and now let's simplify that out a little bit by multiplying. Let's not make this a product rule, let's just FOIL that out. So A equals, right, so 24Y times Y is going to be just 24, the Y's will cancel. And then outer, Y times 2 would be 2Y. Inner, we have 3 times 24 over Y. That's going to give us plus 72 over Y. And then the last terms, 3 times 2 would be 6. So let's combine our like terms. Our area is 30 plus 2Y plus, let's just write that as 72Y to the negative 1. All right, and so now this is our new primary equation. All right, we took took those inside areas and outside areas and combined them together, right? And we solved for one of the bit. We took the information we knew. We knew that inside part had to, the writing had to, that area had to be 24 inches. We used that to solve for a variable, right? And then we represented the area as that writing plus the margins in there. All right, so don't be afraid to try different paths until you get an equation that represents what you're trying to do. By the way, I have to have an area equation because I'm minimizing area. All right, so perimeter equation wouldn't do me any good if I'm minimizing area. All right, so make sure that your primary equation is going to address what it is you're trying to do. Now we can take the derivative. and solve for, in this case, y. So we have our equation, our primary equation is a equals 30 plus 2y plus 72y to the negative 1. All right, so we take the derivative. This time it's with respect to y. So dA dy equals, derivative of 30 is 0, derivative of 2y is 2. Derivative of 72y to the negative 1 would be negative 72 times y to the negative 2. So dA dy is going to be 2 minus 72 over y. And just looks okay so far. All right, so now we need to set it equal to 0, right, and solve. So we have 0 equals 2 minus 72 divided by y. Let's add 72y to both sides. So 72 over y equals 2. We'll cross multiply. Right? So you've got 2y equals 72. Divide by 2, y is equal. Oh, I'm sorry. When I wrote it down, I lost the square. I'm like, that's not right. So sorry. Right? So notice I just rewrote it again so that we could plug in. When I simplified it, I just totally left off the square on that. It's y to the negative 2. All right, that looks much better. So it'd still would be instead of, it'd be 2y squared equals 72, and y squared equals 36. That means y is equal to positive 6 and negative 6. But remember, both x and y, their dimensions, they have to be greater than 0. So our critical point is going to be y equals 6. All right, so now we need to take the second derivative, and then we'll solve for the dimensions. Right? So second derivative to analyze. All right, so we have, and so right here is our first derivative. So d2a over dy2 equals, derivative of 2 is 0. Right? And so, by the way, this is, I'm going to actually write it over here again. So dA dy equals 2 minus 72 times y to the negative 2. Right? So that's going to be 144. And it's going to be y to the negative 3 now. All right, so now if we, or if I move it, it's going to be just y cubed. All right, and so now if we plug in our critical point, which was 6, right? So d2a dy2 evaluated at 6 would give us 144 divided by 6 cubed, which is 144 divided by 216. That is positive. So since f double prime of 6 is greater than 0, y equals 6 is a relative minimum. Right? Or concave up. Right? So that's a minimum. Concave up because the second derivative is positive. All right, so now this was step 1, or our diagram. Step 2 is our primary equation. Notice we start with the primary equation. Usually there's a problem. Go to your secondary equations to reduce your primary equation to one variable. Take care of those constraints. Then step 4, you can take your derivative and solve for your critical point. Use the second derivative to analyze that. And then step 6, you can answer the question that you were asked to answer. All right, so I think I'll do that on the next page because, well, it's getting a little full in here. Though I guess I could squeeze it on the bottom there underneath the primary equation. Maybe it's just better to give ourselves a new page All right, so first we know y is 6. We need a way to solve for x. Remember that inside area, that will do. That was area equals x times y. It had to be 24 inches. And we already know that y is 6. So if you divide by 6, 4 is equal to x. Right? So there's our other, now our dimensions are not 4 by 6. That's the area of the writing. We want the area of the paper. Right? So we want to minimize paper, right? Not our writing. So the equation that will give us our dimensions are right over, I'm looking for the length and the width. There you are. So y plus 3 and x plus 2. This right here, those are the dimensions of the paper. Right? So our dimensions. So you can see the solving is for, once you got your critical values, the solving is really, really easy. Right? So the length going up and down was the y plus 3, right? I know I forgot. I have to change the page. So x, yeah, y plus 3. And then width is x plus 2. All right, so y plus 3. So that's going to be 6 plus 3, or 9. All right, so 9 inches long. And that width is going to be 4 plus 2, and 6 inches wide. All right, so the paper size to minimize area would be 9 inches by 6 inches. There you go. And we didn't have to find the area, though it's 54 inches. All right, so that's that problem there. All right, well, I'm going to end this podcast, and then we'll come back to another problem. All right, bye for now.